everyone, I am PANKHUDI Sharma standing in front of you all to give a very basic introduction on the chapter Gravitation. So let's begin. In 1665, there is a man, 23-year-old, Isaac Newton. He gave a very basic idea to physics about what gravitation is. How? He thought that how is the moon remaining in its orbit and does not fly away? How does an apple fall from the tree? So everything, the moon and the apple, both are attracted by the earth. Not only earth, every single particle in this universe attracts each other. So this leads to the Newton's law of gravitation. What does it state? It states that two particles attract each other through a certain force, and that force is directly proportional to the product of the masses of the two objects and is inversely proportional to the distance traveled and its square. What did I say? Let me explain. Suppose here is an object A and object B. So object A and object B have certain masses. Let this be mass 1 and let this be mass 2. They have certain distance between them. So I'll measure the distance from between the objects as gravitation is a central force. We'll discuss about it. So here is certain distance, let the distance be d. So according to Newton's law of gravitation, force is directly proportional to the product of masses of the two objects, that is m1 and m2, and inversely proportional to the square of the distance, that is b square. Right. So to use this in calculations, we have to form it as an equation. So we'll remove this proportion sign and put an equal to, and we'll use a constant instead of the proportion sign. That constant is capital G. That is known as the universal constant, gravitational constant. So which is multiplied with the masses of the object and distance square. Now here, the universal gravitation constant is constant throughout. It has a certain value. Its value is 6.673 into 10 to the power minus 11. It has its specific SI unit, that is Newton meter square per kg square. Where did we get this from? For this, we'll have to use this formula. For this, we use capital G in the LHS, and in the RHS, we take force multiplied by distance squared upon m1 into m2. That equals to, SI unit of force is Newton. SI unit of force is Newton. SI unit of distance is meter. Distance squared, that is meter squared, upon mass into mass, that is kg into kg, that gives kg squared. Hence, SI unit equals to Newton meter square per kg square. Now, we're clear with what gravitation is, how it works, and about its SI unit and everything. So now, coming to the next topic, that is gravitation is a central force. How do we define that? Well, there's no specific definition for this. Suppose, I'll give an example. Suppose this is our earth. Here's an apple tree. Apple falls from the tree. Right. So, from the center of earth, gravitation force will pull it. It won't pull from the side, not from the bottom. No. It will just pull from the center. This means that gravitational force, when applied, pulls the object towards its center, any object. Suppose, like as I had given example above, objects A and B. From the center, object A will attract object B from its center and try to pull it towards its center, and object B will try to pull object A towards its center. So I have a limited time, so let me wind up. So we have studied about gravitational universal constant of gravitation, and its value is 6.673 into 10 to the power minus 11. Its SI unit, Newton meter square per kg square, and how gravitation is a central force. That was all for today. Thank you.